and welcome. This is a screencast video for those of you who are taking EDUC 6023 Research 1, and this is the first of 4 screencasts that's going to give you a working vocabulary on measurement and research concepts and terms. Now, I don't mean to imply that if you look at all of these screencasts together you're going to know all you need to know about this, but it's going to give you a beginning vocabulary. Let me explain what's going to be happening and what's going to be available to you. The first one, which I'm going to be doing right now, is called measurement concepts. And it's part of a set of 4 screencasts. The next one in order that you'll want to look at is research concepts. The third is memory jogger tools. And then finally, there is a 4th video, and it will be in reference to an Excel file that will help you in 2 ways. Number one, the Excel file is going to provide tutorial sheets to help you if you need help with meeting the Excel skill requirements, which is assignment 2 for the course. And finally, you're going to find some really great examples of data, and this is real data in this form that you're going to be able to use to explore some of the concepts we're talking about here. So you're going to see a really great example of real reading scores. They're a little outdated, but they're really good information to show you how a big data file works. And then I've got 3 sets of files that show a relationship of proficiency levels with free and reduced lunch levels for 3 different groups. One is for a huge group of 100+ elementary schools in Sedgwick, Butler, and Harvey counties. Then I added a new one this year for looking at schools in Ford, Finney, and Gray counties. And then to show how this changes a little bit when you add a little more diversity in schools and also more schools, bigger numbers do make a difference here. I added schools in Douglas County. So you've got some really good examples to look at here and work in here. Let's get about our process on measurement concepts now. And anytime we're looking at data, whenever you see data, and data can be a set of test scores, it can be a set of heights for a group of students that you want to measure height on. It could be running speeds for 100-yard dashes. It could be quiz data for an activity you're doing in class. Could be lots of things. But when you get the data, you're going to have data for a group of subjects. And the first thing you need to do is you need to structure the data. And this requires you to create something which is called a frequency distribution. And I'm going to make reference to the reading scores sheet in the Excel file to help you out, because if you do your work on the Excel, you're going to see a help sheet that's going to help you develop the concept of creating a frequency distribution, and then it will show you, so you'll be able to example. But you need to get the numbers organized, and so that means put them in a rank order, order the frequency, because a frequency distribution is nothing more than a list of the number of scores at which possibly people scored at, and then the number of cases. In the reading score example, for an illustration purposes, I have a big data file with about 325 cases. They're all reading scores from a high school reading test that was done a number of years ago. Names have been changed to protect the innocent, obviously. So 100 points possible, but not everybody got some of the low scores. So you could go in and you can see there for each score value that somebody scored at, it shows how many people scored at that value. Then you're going to create some examples of what we call measures of central tendency: mean, median, and mode. I hope by this time I don't need to do a lot of description of what a mean, a median, and a mode is, but I will tell you for 2 of those concepts, mean and median, the 2 that are most useful, the Excel help steps are going to help you a great deal in being able to computate those measures of central tendency. Then we're going to be looking at measures of distribution of the data, and I'm going to give you 3 examples of doing that. So you can use something called a mean and standard deviation. And a little bit later in this presentation, I have a view of a normal distribution, commonly called a bell curve, so you'll be able to understand that. but it is one way of looking at how much diversity there is. So in other words, we're looking for the pattern of distribution for the group of scores we're looking at. And if you're looking at any group of test scores, you're going to see a pattern. It depends on the nature of how we're testing and what the concept is, but we're going to look at that a little bit. Or you could arrange it by quartile groups. In other words, lowest quartile is 25% of cases, second one 25% of cases, and up and down the line. So you get 4 groupings of quartiles. Now there are some problems with doing that, so if you're not sure you want to get into the concept of looking at a standard deviation, here's a better way to do that. You can group the distribution of scores by putting 15% of cases in the bottom group, 35% of cases in the second group, 35% of cases in the third group, and 15% of cases in the fourth or the top group. Now that pretty closely approximates the distribution percentage-wise of a normal distribution. And it's kind of helpful because by looking at the bottom 15 and the top 15% of cases, you can much easier make sense out of the outliers. Kids who are in the bottom 15% of any group probably deserve some special attention. Why are they in that group? Why are they having difficulty keeping up with the group? And so on and so forth. So again, you want to be able to look for a central distribution, and you want to look for where the center of the distribution is and how the group of numbers is distributed. Okay, let's go on to some concepts you've probably heard a lot before, and one of the things everybody hears about is the concept of reliability. Well, reliability is nothing more than a measure of consistency. Now, reliability in a measurement tool is really important because if we don't have reliability, we don't have anything we can attach any meaning to. So we just can't have random measures and say, well, that's what we're going to base our scores on. So reliability is what you do when you have a test scores, for example, where you have a fixed response assessment. Multiple choice, true-false tests are fixed response assessments. And it really looks at the consistency of answering patterns of looking at the interrelationship of items on the test. Now, for example, what you'd be looking at, well, some commercially produced multiple choice test batteries will yield correlations of 0.9 or higher, a high agreement here. And you're going to get a lot of opportunities to look at this idea of what a correlation coefficient is, so you're going to get some ideas on that. Number of items, the number of cases make a big difference. So if you have a class quiz with 10 questions and you're giving it to 25 students, you're not going to get a reliability of that kind, so don't expect it. A more common thing that we've come to in recent years is rater agreement, where we have something which is a constructed response assessment. So those of you in Kansas who have worked on writing assessments, or those of you who have developed open response math assessments, those are constructed response assessments. So as you know, these are the factors that are going to influence your measures of consistency when you're using those measures. One is you got to have a really clear rubric, really clear game plan, so one can look at the rubric and tell clearly, here's the identification of a really good score measure, a set response on this, and here's a measure of something that doesn't look very good. And you need lots of training of raters. So people who simply give a constructed response assessment and assign a group of teachers or community members to read the items, expect you're going to get some meaning out of that, are going to be sadly mistaken. If you're going to use this seriously, you need training, you need to work on it, and you also need to keep after the process while it's going on. Some commercially produced writing assessments will yield agreements of 90% or higher of holistic assessments. In other words, that means when we have 2 raters, they're going to agree more than 9 out of 10 times about the specific rating they're provided. Now again, these are cases where people have really worked on clarifying the rubrics, and there's constant ongoing training of raters and checking to see that we don't have what we call halo effect or drift. Okay, measures of consistency. The next thing you want to look at is, you've heard the term validity. And validity is really what attaches meaning to a set of numbers. So are we measuring something that makes sense? Here are 4 examples. I won't go spend a lot of time on that. The most commonly used in school settings right now is the idea of what we call construct validity. So that's usually a judgment call by a group of experienced educators or a group of community members who have special knowledge of the concept, and so they're simply going to look at assessment questions and concepts measured, and they're going to say, does this make sense? But we need to pay attention to the other things. Predictive validity, for example, is what we give when we use the ACT test, because the whole purpose of ACT test is to look at predicting the probability that a student's going to be able to succeed by staying in school for at least 1 year when the student goes to college. So that's the whole meaning. It's not, when you get a ACT score of 24 in English usage, the whole point is you compare it with the group of English usage scores for the institution you're going to, and they can give you an idea of, based on previous success, what's the probability of success for this individual. Concurrent validity is another concept which we won't go into very much, but sometimes we have an expensive measurement and we want to know if a less onerous or difficult test could do the same thing. It's kind of similar to finding out in medicine if we could find less invasive procedures to do a medical process. It's the same thing here. So for example, if we give a group ability test, if it's important for us to know this, is that going to be a good is that going to be similar or going to have a good agreement to an expensively individually administered ability test? Moving on here, one quickly cop out here. If you do anything with surveys, opinion or preference measures, in other words, something where you don't have correct answers, you don't have reliability issues, but validity and meaning is really a big issue, so you need to pay attention to that in that case. Quick review, not going to pay much attention. These are frequently used measurement terms. I'll leave you to read those on the process but the first 4 are probably the ones we looked at. Norm reference means we're doing all it means is we're comparing the results in a normative sense with people who have taken the test in similar circumstances in the past. Criterion means are you measuring against a set standard? Here would be a simple commonplace example. Suppose we did a high jump of people in the class. If we did it by comparing to see who could jump the highest, that's a norm reference test. If we did it by saying how many people can jump a set measure 3.5 feet or something like that, that's a criterion reference measure. I'm going to let you go through the rest of those because I want to spend a couple of seconds here at the end looking at the concept of the normal distribution, commonly called the bell curve. Now you've all seen this kind of, and I didn't throw the curves in it because it's kind of hard to do in PowerPoint, but this is a description of the process. A lot of people look at the normal distribution and think it's something of a theoretical construct. It's not. If we went out in the city of Wichita and we got 1,000 people that were randomly selected from the community, effectively a good distribution of people from the community, and we did height measurements and we put it on a graph, it would come up looking very close to the normal distribution. Some measures do that, and here are 2 examples down here below. The SAT test is a normal distribution process, scores. The Stanford-Binet IQ test uses a normal distribution of scores for measurement processes here. Now this works pretty well in working with many human measurements, but we're going to talk later about some research, some cases where don't apply with this. Again, a beginning of a vocabulary, just enough to get you started. We will continue this when we start to look at research concepts.